But I was set up really well by Colonel Silver from the Rapid Equipping Force earlier, because he talked about the project SOTA using the Tether drones, and that's what I'm here to talk about today, the Tether drone. We have one back there, and here we go. Nope, not me. Cyphy. So really excited to get those drones deployed with the Rapid Equipping Force. Oh, here we go. And I thought, because we're in the innovations corner, I would take some time and talk a little about the technologies that in a tethered drone. So if you go, so the tethered drone uses an active tethering system, and data and power is provided right through the tether. And it's not as simple as attaching a cable to a drone. It's really, it's a really tight combination between the weight of the microfilament, the resistive losses, and the wind drag. And our system consists of more than the microfilament tether. There's a power generation that can run off a wall voltage or a generator. It goes to an active spooler that lets out the microfilament and reels it back in, and it also actively manages it in the face of wind. And then the microfilament tether that does the power and communications transmission, and then we have a down converter and data modems to take the data off the wire. And all of this is in a package. You can see it in the back table over there. That's smaller than the headphone size of your earphones. So why have an active tether? Well, it eliminates the flight duration problem. Like, a lot of times people are launching UAVs, they land them. With a fixed wing, you can get a few hours of flight, and with a rotorcraft, you're probably stuck with half an hour or maybe even 45 minutes. But our drone can stay up 24/7. We fly it for hundreds of hours. It can fly for days. And that's really game-changing, because you have these persistent eyes in the sky all the time, with very little logistics footprint. It also provides a secure data communications and video. So when the robot's flying, we're always transmitting high-definition video. And that can't be spoofed, hacked, or intercepted, because you don't want someone else seeing your feed, and you don't want someone to be able to take control of your drone. So we worked with the red team with the Army, and they said, well, some of these drones, you know, if you're a really good hacker, you can take control of them. They've taken control of the U.S. military, the Army drones, and in this one, because it goes through the communications, command and control goes through a wire, that's not possible. And also, a lot of people don't realize, if you want to disrupt a drone, you just put a lot of noise into the world, and they can no longer see their communication signal. We eliminate that problem with this drone, and that's almost as important as the power. This is very, very resistant to being spoofed. And it increases safety because it actually acts as a proactive constraint. You may have heard some of the hobby drones have what they call flyaways, where the GPS signal isn't getting through, or it's being spoofed. And because we're on a constraining tether as well, you know the robot's going to be in pretty much the same location that you send it up. This vehicle is designed to go up and stay up. So it acts kind of like a near-Earth satellite system. It's not designed to go out over the next hill. It's not designed to go over a building. But from a vantage point of a few hundred feet, you'd be amazed at what you can see. So this is the park system. It's on the microfilament tether, unlimited time on station, unbroken HD video, and really reliable command and control. And here's a video of it in operation. Whoops, can you play the video? So when you're ready to go, all you do is set an altitude, you press a button, and that causes it to launch. So there's no piloting required. And you can see here's our launch procedure. It just flies up. You can barely see the microfilament tether, but I assure you this robot is being powered from the ground. And this is a satellite image, and it just gives you the idea that this is a near-Earth satellite system. So from a high-up vantage point, you can see with its electro-optical sensor, or you can switch to its infrared sensor. And so you can see on a bright sunny day, or you can see in darkness. And we're not flying too high today because it makes better video down lower. That is getting video of the robot flying. But you can see once you get up over the tree line, you have a really, really wonderful vista on whatever you want to see. Here it is seeing a boat, and it's automatically tracking the boat with its onboard analytics. So the camera's swinging as the boat's moving through the water. And this boat was actually over a mile away. And this storage tank is actually over 3 miles away. So from a vantage point, even where we're flying at less than 100 feet, you can just see a tremendous amount of surrounding area. And this is showing our recovery. All you do is push another button to land. Again, no piloting required, and the vehicle ends up exactly where you launched from. So this is for fixed site operation right now. You can imagine at a combat outpost, you don't have either the resources or the logistics train to bring in a large aerostat vehicle. And this is basically a version that you can have eyes anywhere you need them, all the time, persistently. But we also have a lot of customers saying, hey, can we do that on the move? Can we put it on our trailer? Can we put it on our Humvee? Can we put it on, on a Bradley? Can you put it on a boat? And the answer to all those questions is yes. We're working on that right now. It takes a few more pieces of technology, the tracking, the precision launch and recovery, and there's no reason why this vehicle can't be, with a boat, on a trailer, 24/7. You drive it to where you need it, and if you want to go to a different location, you just head out, and the drone follows you. So a very, very different kind of a drone system from what's available today. Again, more like the near-Earth satellite system. So all this was based on this new, really innovative tether technology. And so we asked ourselves, what else can you do with this tether technology? And so this is Pork's little brother, the Pocket Flyer. Pocket Flyer is designed to go into your cargo pants pocket. So you have it in a container, have it in your pocket, and I like to say the best robot is the one you have with you. It's the one that's going to be with the guys when they need it. And because it's flying, it has the mobility to get anywhere. And because it has the microfilament tether, a vehicle this size would literally last 10 minutes if you had batteries on board. And unfortunately, probably less if you had solar cells on board. But with the microfilament tether, you not only have that long-term operation, but also when you go into a building and you lose line of sight, you still have your command and control signal, and you still have your real-time situational awareness coming all the time. So here's a short video of Pocket Flyer. Pork we have available now. The Pocket Flyer is still in development, but it's really exciting as well. And can you play the video? So you can see it has a microfilament tether, which you can barely see, and it's spooling that microfilament from the vehicle. So the first question I always get asked is, will it snag? Will it break? And the answer is no, because you never put any tension on the microfilament. It's always spooling out. It's like laying down a track, like a spider spinning a web. And it is disposable. It's very cheap. It's just magnet wire. But with our communications technology and with our power technology, you're powering the vehicle from it, and you're doing full HD communications. In fact, this robot's going to have 10 cameras around it, and we stitch all those together to give it, like a bug, eyes in the back of its head. Okay, that's it, but I'm happy to take any questions about the tethered drone technologies. The question is, what about birds? And the answer is, birds seem to be attracted to UAVs, and we've had them circling, but so far they've always had the intelligence not to get near these high-speed spinning blades. And I think they, maybe something evolutionary in that. I'm sorry? With the tether? We haven't seen that happen. I think they, we just haven't seen it happen, and we've been flying, days at a time.
Helen, was there obstacle avoidance technology in the one you just showed, or I mean?
The obstacle avoidance technology in the first generation will be done with infrareds that are part of the camera system, but we have a design for a small scanning LiDAR system that's still in research, but we'd like to see that on a future generation, so you can make not just avoid things, but make a full three-dimensional model of the environment.
Now, in that case, it was tethered, unmanned, but it could be remote controlled.
Yes, it can be remote controlled, so you can you control it with your cell phone and have it go wherever you want it to go. It's designed to go into a building, like into a search and rescue operation, or if someone's taken a hostage. It's kind of what the ground vehicles are doing now, but instead of worrying about rough terrain, worrying about a fence, worrying about a stream, you can just get anywhere with a small flying vehicle, and then when they're also able to go indoors and not lose command and control and imagery when they, when they lose line of sight, that's really powerful. So it's kind of like the holy grail to me of mobility, getting a robot that can get and see anywhere. Any other questions? Well, thank you for your time, and come see us at the booth back in the left.
Thank you.